In this video we have two trigonometric equations to solve, and we want solutions in an interval from 0 to 360. The bracket on the left means 0 is included. Parentheses on the right means that 360 degrees is not included, so it has to be strictly less than 360. Now we've done some in the past where we used trig identities, did some factoring, basic algebra, quadratic formula. In this one here we're going to use the graphing calculator. First I want to remind you that if you have some function y equal f of x, so this could be y equal, say, x squared minus 2x plus 1. It could be y equal, and then I could have some trig expression here. If I were to put that in my graphing calculator and graph it, and in this case we're working with trig functions, and I could have a graph that looks something like that. And anywhere the graph crosses the x-axis, so that'll be 1 point right here, 1 point right here, and then this could oscillate, come back over here. I could have another intersection point. So this would go from 0, if I'm dealing with degrees, this would be from 0 to whatever, 360 in this case. If it was in radians, 0 radians to 2 pi radians. Anywhere it crosses the x-axis, so let's say this point right here would be the point x1 and 0. That would be an x-intercept. Over here I'd have another one. And notice the second component is 0. So x1, and as many as I have here, would be the zeros, which of course would be the solutions to the equation f of x equals to 0. So if I want to solve the first equation using the calculator, what I'd have to do is rewrite it as 4 cosine squared of x, take this over to the side, or add it to both sides, give me a plus 12 sine squared of x. Take this over to the other side and be a minus 8, and this will equal to 0. And this right here then would be your f of x. So if I put that into the calculator and graph it, wherever the graph crosses the x-axis, that would give me the x-intercepts of that graph. At the same time, the first component of those points would give me the zeros, which of course would be the solutions to this equation. So I've already entered the function on the calculator. So here I'm using the virtual TI-83 plus. Y equals, here's where I would enter it. So here I have the first one already entered, just to save time. So notice the equals here, y1 equals 2, and this expression that I put right here. It's cosine of x quantity squared plus 12 sine squared of x minus 8. And it's already selected. So if I hit the graph key here, there's the graph. Now, I want the solution in degrees, so I want to make sure that the calculator is set to degrees and not radians. So for the mode, you can see it's in degrees. If I want the answer in radians, I could first find it in terms of degrees and then multiply each solution that I got by pi over 180 degrees. Cancel the degrees, and it comes out in radians. Now one way I can get these solutions, especially if they're exact solutions. If it's not, I'll give you another method here, but you can see right here, we're only interested in 0 degrees to 360. So the first intersection to the right of 0 here is right here. And there's another one over here, another one over here, another one over here, and then it keeps repeating. So it's going to have an infinite number of solutions, but I only want the ones in the interval from 0 to 360. So one way we can do it is hit your trace key. And you can see right there, 45. And notice that y equals 0. So this tells me that that point right there is the point 45 and 0. It's an intercept, x-intercept. So one solution to this one is 45 degrees. And then I just keep going, hit the right arrow key here, until I get all of them. Again, notice here, 130, y equals 0. Now, if you don't get a 0 here, then that tells you it's not an exact. It might give you an approximation. But this one has exact ones, so notice 135 degrees. And then I keep going. So I'm still doing the trace of the graph, hitting the arrow key to the right. And slow down when you get close to the x-axis. Notice there the point 225 and 0. So 225 is another solution. And we keep going. Notice here, again, this has to be 0 for it to be a solution or a 0 of the graph. Now let's keep going. Getting close to the x-axis here, so we slow down a little bit here. And notice 405 and 0. That's another solution because it has a 0 there. But remember, we only want the solutions in the interval from 0 to 360. This is over larger than 360. So we stop there. That's it. So the solutions to this one then, we get 45 degrees, 135 degrees, 225, and 315. Again, there's an infinite number. These are just 4 of the ones requested in the interval from 0 to 360. 45, 135, 225, and 315. So this is going to work out nicely if it has exact solutions. So how do you know if it has exact solutions? Well, you can go ahead and just do the trace. And if it doesn't give you the y equal to 0, that tells you that whatever it gives you is an approximation. So what you do then is this. Agree with this? That's the solution to the first one. Now for the second one, if I want to do the same sort of thing, now this one you could just use the regular calculator. It doesn't have to be a graphing calculator here. We could take this over to this side, take this over to this side. That gives you a 1, and then divide by 8. I get sine of x is equal to 1/8. And I can just use the inverse of sine, and I can get my 2 solutions. But let's go ahead and do it the same way. One side has to be 0. So this will be 8 sine of x. Bring this over to this side. Okay, minus 1 equal to 0. And then this will be your y1, which you would enter in the calculator. And that one I've already selected here also. So let me deselect the first one we did. What I do, I just clear it. Okay, and then I want to select this one here. So I'm graphing the 8 y1 or y equal 8 sine of x minus 1. Hit the graph here. So you can see that to the right of 0 there's an intersection right there. So that would be one solution. So if I do the trace, notice here, if I do the trace here, so let's go up, and there's the trace. So I already want the values again from 0 on. So this will go here, go up. And notice I get 7.5. But notice the y value. We wanted this to be 7.5. We wanted y to be 0, not 0.044 and so on. Because if it's 0, that tells me that we have an exact value for the 0 of the graph. But we can get more accurate than that. So in this case, the trace is not going to work in this one. I'll get something that's close, but not close enough. So here what we'll do is we'll use the 0 feature of the calculator. So go to the calculate menu here, go to second key and calculate. I want 0. So hit 2. So notice on the lower bottom of the screen here, we want a left bounce. So we want this cursor to be to the left of that point where it crosses the x-axis. So somewhere in there, as long as it's not on the line, on the axis, and hit enter. It's asking for a left bound. So I hit enter. Now it wants a right bound. So now I go hit the right arrow key and get up above there, right in there. As long as it's above there, hit enter. Notice now it wants a guess. You can ignore that and just hit enter. Now notice it tells you a 0 is found at x equal to 7.180755 and so on. And notice the y value is 0. So this value for x, 7.18 and so on, and y equals 0, that's an x-intercept. So the 0 for this equation, which of course turns out to be the solution to the equation, is x equal to, in this case, one solution would be x is equal to, I'll run that out to 2 places, 7.18. And we're working with degrees here. This would be degrees. So that's going to be one solution. If we wanted radians, we can multiply that 7.18 degrees by pi over 180. The degrees would cancel out, and the answer I get in decimal, if you want, would be in radians. But here it's in degrees. Okay, so that's one solution. Now the other one's going to be somewhere over here. See, the next one will be right there. So again, let's go second, calculate. Again, I want 2 here. I want a left bound, so I want the cursor to the left of this point right here. So let's hit the right arrow key here. There comes the cursor right there. So right there, I want it to the left, so I have it. Doesn't have to be right, real close to it, as long as it's somewhere in there. Hit enter. Now it's asking me for the right bound. So I go past this point. So now it wants the right bound. Okay, so hit enter. Now it wants a guess. You can ignore it and just hit enter. And you can see it's 172 point. Round it out to 2 places, 172.82, and that's in degrees. So the second answer then, 172.82. And notice this is what you would expect. The 7.18 degrees and the 172.82 are supplementary. They add up to 180, which is what you would expect for the two solutions in the interval from 0 to 360. Now, do we have any others? Well, notice over here, another intersection point would be right here. But notice, that's 360 right there. So there are other intersections, but they're outside the interval from 0 to 360. So we can stop right here. And these are the two solutions in the interval from 0 to 360. So it's 7.18 degrees and 172.82 degrees. Thanks for watching. We'll see you next time.